Okay, so tonight I want to talk a little bit about more integration by parts stuff. So I think we left off the other day doing one like this. It was, and of course my pen isn't going to work because obviously everything hates me. One moment, please. One moment. All right, I'm going to run my finger. I don't care. Whatever. So the other day we did ones like this. It was like the integral of 2x minus 7 over, I don't know, x squared plus 1, x minus 2 dx, something along those lines. So as you know, it's going to be 2x minus 7 over this denominator is equal to, and of course you got a over the linear term, plus bx plus c over this quadratic term. It doesn't factor. And I know what you're thinking, Groom. Um, Come on, it'd be nice if this damn thing would work. Darn it. Anyway, so you're thinking, why would we do that? Well, we have to have this linear term over a quadratic. This is how it works out. If you don't, you will not end up with the appropriate amount of unknowns you're solving for. I mean, that's the game here. We're doing some algebra. So algebraically, it has to work out like we need it to. What is going on here, bro? Will the down arrow key work? The down arrow. Oh, for God's sake. You got to be joking me, bud. Can we just... One moment, please. Oh, see, was that so hard? Piece of crap. I draw with touch again. All right, now, let's try this again. So if you multiply by your denominator, you get, of course, x squared plus 1 times x minus 2. Of course, nothing wants to write now at all because, obviously. And so you end up with 2x minus 7 ax squared plus 1 plus bx plus c times x minus 2. So if you do this right, you get 2x minus 7 ax squared plus a. Again, this does not have zeros, so you can't do the other method. Plus bx squared minus 2bx plus cx minus 2c. Okay? Now, again, what are we going to do? We've got to match up all of our pieces and parts. So our pieces and... Damn it. So our pieces and parts... Unbelievable. So our pieces and parts are this. A plus b equals 0. Because there is no x squareds. And then a minus 2c is equal to negative 7. And negative 2b plus c is equal to 2 because those are your x's. Yes? Now, again, a couple ways to do this problem. If you have a calculator, this is kind of nice because what a guy could do is write this as a couple of matrices. And so, for instance, and this is just an idea here, you can use matrix solvers, you can do all kinds of things. So you can have 1, comma 1, comma 0. That's, you have a plus b plus no c's on the first one, semicolon. A, so it's 1, comma 0, comma negative 2, and then semicolon, and this other one is going to be 0. Oh, damn it. It's going to be 0, because there's no a's, plus b, no, plus 2b, but, oh, minus 2b, uh-oh, negative 2b, and then 1, and then times that by your answer matrices are 0, comma 7, comma, or negative 7 rather, comma 2. And then the problem is you have to transpose that because that's wrong. Oh, you dumbass. So our answers are -7, -4, and 16. I'm going to write that down somewhere. So -7. -7 over x minus 2. And then minus 4x over x squared plus 1. And then plus 16 x squared plus 1 dx. Now I'll do the hard part. Yeah, this guy here is 16 arctangent plus c, of course. The middle one, if you let u equal x squared plus 1, then du is equal to 2x dx. Which I kind of have that, yeah? I just have -2 times that. So I have -2 du over u. So, of course, that's -2 ln of u. And then, of course, the first one is just going to be -7 ln of x minus 2. Okay, there it is. You're done. You're home free. Okay, I'm really getting peeved about this pen. I'm going to pause for just a moment. All right, we're back. Helps turn the battery in the right way, idiot. All right, so there we go. So we are going to do another one. I'm going to do this one. 3x squared plus... No, 3x. I don't care. It doesn't matter. I don't really care anymore. Whatever, bro. X squared plus 4. 2x minus 1. Oh, that's hot, Groom. I know, right? So here we go. So we're doing this problem, of course. 3x plus 4 over your denominator. X squared. What the hell? X squared plus 4. Yeah, gummit. 2x minus 1 equal. You do you. I'm going to do my a term over my linear guy, but it doesn't matter at all. Good night. Anywho, when you multiply by the common denominator, you will end up with... Gosh darn it, you piece of crap. Darn it. Yeah, that's what I want translated. That's what I want, idiot. Gosh, I hate this piece of crap. Of course. Damn it. Just a minute. One moment, please. Hold, please. Oh, hey, look at that. Good night. Anyway, 3x plus 4 equals ax squared plus 4 parentheses plus and now the eraser doesn't work. Well, now the whole pen doesn't. Oh, you got to be joking me. I love my life. I love my life. It's the best. I love it. I love it. I love it. Yeah, why don't you throw the battery at yourself, dumbass? All right. Well, one moment, please. Ouch. All right, Mr. Groom. Can you do it? Probably not. Hey, look at that. Might actually work now. Weird. Nope, still not going to work. So my pen is running out of ink. Okay, we're just going back to my finger. I don't care anymore. Okay, that's going to leave you 3x plus 4, ax squared plus 4a plus 2bx squared minus bx plus 2cx minus c. C! And then, if we do this right, we're going to have a plus 2b is equal to 0. There are no x squareds. We know that 4a minus c is equal to 4 because those are my constants. And then for our x's, it's negative b plus 2c is equal to 3. Couple ways to go about it. You do you. I don't care. A guy could put these two together right here, and you'd end up with another equation that's in terms of only a and c. Then I'd have two of those. Okay, so for instance, suppose I times this guy by 2, and so I'd end up with negative 2b plus 4c is equal to 6. Now, if you add, you're going to get a. The b's cancel out, plus 4c is equal to 6. Of course, you've got 4a over here, minus c equals 4. And you're like, oh, I can solve that now. Of course you can. So let's times the top one by 4, I guess, because we can. So that's 4a plus 16c equals 24. Now let's minus, shall we? So if you minus, I'm going to get negative 17c is equal to negative 20. So c is 20/17. You know, I guess, whatever. Get your calculator back out here, and then let's go. So clear. 6 minus 4 times 20/17. So a is 22/17. And then let's scroll back up here. What's b? Well, b is equal to, you take this guy here, b is equal to 2c minus 3. So since c is 20/17, 2 times 20/17 minus 3, negative 11/17. Okay. Yay! What does that do for me? Well, again, your a, so which is 22/17, 1 over 2x minus 1 dx. Then the second part is, oh shoot, you dumbass. The second part is plus bx, and so it's going to be minus 11/17 minus 11/17 x over x squared plus 4 dx. And then the last one, the c, is 20/17. So plus 20/17 1 over x squared plus 4 dx. And now we are where we came for. Okay, this is why we're here. So let's do this. That's going to be 22/17 ln of 2x minus 1. Remember, you need to divide by 2 because this is a u right there, and my du is going to give me a half. So what should have happened right here is this should end up being 11 because I divided it by 2. Okay. Yay. Ditto here. This is going to be a 2x. I'm going to have a half. So it's going to be minus 11/34 ln of x squared plus 4. And then the last part's the tricky one, right? Because you're like, oh, wait, what? So what I need to do is I need to take a 4 out of those two guys. X squared over 4 plus 1, right? And so that's now going to be 5/17 out front because that was in the basement. Okay, and then what is this? Well, then if u is x over 2, du is equal to 1/2 dx. So I have 2 dx's. There's 2 du's. So it's going to be 10/17, right? Integral of 1 over u squared plus 1 du. So it's going to be plus 10/17 arctan of u, but u is x over 2. And that's my answer. Yay, and the crowd goes wild. Okay. Pretty slick, pretty good. Like the last one I want to look at tonight, we did one in class the other day. Just want to give you another example of it. Suppose you ran into this beast in a dark alley. Okay. So easy. Since it's a repeated root, it's a repeated linear root. Okay, well then we need to do the we need to do it with b over it, and then also c over it squared. Okay, again, if you need something to think about, if you need something to think about in your mind, why is that? The way I like to think about it is that it's very much like if you have the factors of 75. They are, 5 and 25, right? And so you'd have 5, something over 5 plus something over 3 plus something over 25. Okay. So if you multiply through, you get 2x minus 3 is equal to ax squared plus b. And then this guy needs one more x, and he needs an x minus 2. This guy just needs an x minus 2. Now they all have the same stuff. Yay! So 2x minus 3 is equal to ax squared plus bx squared minus 2bx plus cx minus 2c. So right off the hop, you see that c is equal to 3/2. Yes? Everyone see that? It's pretty slick, man. And a plus b is 0. Which means that a is equal to negative b, which is hot because now I got negative 2b plus c is equal to 2. But since a is negative, I'm not there yet, sorry. So if I put this in, then I get negative 2b plus 3/2 is equal to 2. Let's get my calculator out. So 2 minus minus 3 halves is that divided by negative 2. What the Sam Hill? It should be negative a quarter. Should be negative a quarter. Okay, so it should be negative a quarter. That's what B is. B is negative 1/4. And that means A is positive 1/4 because they're opposites. Yes? Yes. Excellent. And so you have A over X minus 2. So 1/4 integral 1 over X minus 2 dx. Plus B is minus 1/4 1 over X dx. And then C over X squared, and C is 3 halves, plus 3 halves, 1 over X squared dx. Okay? And so this first one is 1/4 ln X minus 2 minus 1/4 ln of X plus, now this is the antiderivative of X to the minus 2. X to the minus 2, so it's going to be negative 3 halves X to the minus 1, or if you prefer, times 1 over X plus C. That's it. All right. Hope that helps. Bye.